Today's class we were doing differentiation. Hope you can see that there now. Okay, so if we want to differentiate a function like y equals 4x squared plus 2x plus 6, you bring the power down in front, so that's 2 times the 4, which is 8, and you subtract 1 from the original power, so that's x to the power 1, or just x. There's a 1 here, so you bring the power down in front, you subtract 1 from the original power, you'd be left with 2, and then this one will go to nothing, so we'd have x to the power 0. And then here we have an x to the power 0, so power 0 comes down in front, subtract 1 from the original number. But anything by 0, when you bring the 0 down in front, you'll just end up with a 0 here. So you can write in your 0 if you want, but really that's just a waste of your time. So there you go. If that's your original function, this is the differentiated version of that function. So this is the rate of change of that function. The next question was y equals, right over here, y equals 3x squared plus 10x plus 2. And again, you bring the power down in front, subtract 1 from the original power. So the 2 goes down in front, so that's 2 times 3, which is 6, and you subtract 1 from the original power. So x plus, or x to the power 1. We have an x to the power 1 here, you bring the power down in front, you subtract 1 from the original power, and you end up with a 10. There's a 0 here, you bring the 0 down in front, so it's an x to the power 0. 0 times anything is 0. So if that's your function, and it would look like a U shape if you graphed it, then this is the differentiation of that function, or the rate at which the function is changing. Next question. X squared plus 9x plus 12. So I bring the power down in front, so it's a 2 times x, and I've dropped 1 from the original power there, and plus, as the 1 comes down in front, and I subtract 1 from the original power, so 9 times 1 is 9, and this goes to, no, I have x to the power 0, and here I have an x to the power 0, so 0 comes down in front, so anything times 0 is 0, and I'm done with that one. Then we have y equals 3x cubed plus 4x squared minus 3x plus 8. Again, I bring the power down in front, so that would be 3 times 3 is 9, and I subtract 1 from the original power. 2 times 4 is 8, and I subtract 1 from the original power, or 8 to the power 1, sorry, x to the power 1, or just x. And then my 1 comes down in front here, subtract 1 from the original power, and end up with 3. And then, as always, the 0 comes down in front, and I multiply by 0, 0 times anything is 0. And the very last one that I'm going to do here that we looked at was y equals 3x squared plus 4. You bring the power down in front, that's 2 times 3, which is 6. You subtract 1 from the original power, x to the power of 1. And then if you're going to do it with this, there's an x to the power 0 here, the 0 comes down in front. So you can write plus 0, or you can just leave it. So if that was your function, this is the differentiated version of that function, or the rate at which that function is changing.